So in this video, we will look at the gradients of parallel and perpendicular straight lines. To start with the basics, just to remind you, parallel lines are those lines that no matter how much you extend them on either side, those lines will never, ever meet. They will never intersect. And that happens because they always keep the same distance apart. The way we symbolize them is like that. Unlike parallel lines, however, perpendicular lines do meet, but the way they meet is what makes them especially important. These two lines that are perpendicular will always form a right angle, as you can see here. So when they meet, they create a 90-degree angle. And the symbol that we use to show them is that one that you can see there, so P perpendicular Q and vice versa. Now, what does that tell us about the chapter that we're working on? Okay, so we will mention this also further down the line. But when we want to find the specific equation of a straight line, which is always of the form y equals to mx plus c, there are two things that we have to know. We need to know the gradient and we need to know the y-intercept. Knowing the relationship between two lines allows us to find the first piece of the puzzle, and that is the gradient. Okay. So the gradient of parallel lines, this is very important for you to know, the gradient of parallel lines is always the same. Let me just write that down. The gradient of parallel lines is the same. Now, what does that look like? It means that if the gradient of line 1, let me give you an example here. So if our line 1 is y equals to 4x plus 3. As you can see there, there's a gradient, so its gradient is 4. Since the gradient of parallel lines is exactly the same, that means that if L1 is parallel to L2, so line 2, that means that its gradient will also be 4. We don't know the y-intercept at this point, but that's okay. The piece of the puzzle that we're looking for is the gradient. So that means that M2 is 4. So just to repeat that, remember, and just keep it there in your mind. The gradients of parallel lines is always the same. Now, the gradient of perpendicular lines. All right, remember also always y equals to mx plus c. The gradient of perpendicular lines, so if we were to have gradient 1, and then we have this gradient of the gradient of a perpendicular line, so let's say gradient m2, which is perpendicular, the product of those two gradients will always be minus 1. Okay? So, let me give you an example. If, for example, we have line 1, and our line 1 is 3x plus 4. Line 2 will be, its gradient will be minus 1/3. See, we don't know the c at this point, but we care about the gradient. So just to prove this to you that it is correct, if I have m1, which is 3, and m2, which is minus 1/3, and I times them, their product should be minus 1. So let's see. Isn't 3 the same thing as 3 over 1? 3 divided by 1 is the same, right? Okay, so that means when we multiply our fractions, don't forget 3 times 1 is 3. 1 times 3 is 3. Remember, this is a positive and that's a negative. So plus times a minus is a minus, and 3 divided by 3 is 1, so minus 1. which is what we said initially, okay? So the product of the gradients of perpendicular lines is always minus 1. Okay, now finding the gradient of the perpendicular lines might seem a little bit trickier than finding the gradient of parallel lines, since parallel lines were rather straightforward, that they were exactly the same. So if line 1, its gradient was 3, then if it was parallel to line 2, then its gradient will also be the same. Okay, will also be 3. So I'm going to show you a trick. So the example that we mentioned earlier was if M1 was 3, I said immediately M2 is going to be minus 1/3. How did I know that? Okay, I'm going to tell you a trick. So I'm going to give you another. This was the example that we used earlier, but I'm just going to give you a fractional example. So let's say we have, let me change colors. Let's pick this. So if gradient M1, so the gradient of line 1 is 4/5, the way to find the gradient of M2, the gradient of if it's perpendicular line, what you want to do is you want to flip your fraction. So 4 will now go to the bottom, so it will be a 4th now, and 5 will be at the top. Okay, so what you want to do is think about it as a fraction that you can just flip around and you reverse it, okay? Now the other thing you want to do is, because the product is going to be a -1, okay, you want there to be opposite signs that are multiplied. So if M1 was a positive, you want M2 to be a negative, okay? So there's two things that you want to do. Just to, before we revise that, let's just prove it. So we have 4/5 times minus 5/4. So first things first, it's a plus times a minus, or a positive times a negative makes a negative, hence our minus sign. And then we have 4 times 5. So numerator times numerator is 20. And then denominator times denominator. So 5 times 4 is also 20. And we know that 20 divided by 20 is 1. So it's minus 1. And there you have it. Now, there are two things that you want to know when you want to use this trick. Let's pick green. The first thing is flip your number. Flip your number, okay? So if it was 4/5, just flip it. Just flip it the other way around, okay? But what if your number was, let's say, let's pick this one. What if your number is a 3? The way I want you to think about whole numbers is think about it as 3/1. It's an invisible fraction, really. So that makes it much easier for you to visualize when you put that over 1, because then you can just flip it and it will then become 1/3, okay? And then you will, we'll come to our second step, which is opposite signs. So if the other one was a plus, then it will become minus, and if it was minus, it will become a plus. Okay. Now this is a bit of a trick. It's not necessarily a conceptual trick. It's more of a mechanical one to make your life a little bit easier. Okay. Now before we move on to the working out section where we will work together, just want to tell you what would happen if you had a third. So what if you have a fraction that is 1 something, so it's 1/3, 1/5 something. So if you have 1/5, again, you will do the exact same thing. You will flip your fraction and will now become 5/1, which is the same thing as 5, so you can take that away. And if the one was a plus, then the other one would become a minus. If the one was a positive, the other one would become a negative. Okay? All right. So if you're not quite sure about this, take a moment, pause this video, read what you can read, try and make sense of it, then go back, rewatch it as many times as necessary for that idea to kind of come through. All right? And let it percolate for a little bit. All right. So now we're going to move on to the section where we get to work together. All right. Let me change colors. Okay. So this question says, work out the gradient of the line that is parallel to the line with this gradient. Okay. What did we say about parallel lines? Parallel lines have the same exact gradient, right? So if they have the same exact gradient, then the gradient of the other line, right? If this is the gradient of, we know the gradient of line 1 is 3. And that automatically means, because it's parallel, it means the same, that M2 will also be 3. Okay? And that would be your answer. That's it. Next, it says work out the gradient of the line that is parallel, same, to the line with this gradient. So it's telling us that M1, the gradient of line 1, is minus 12. Okay, so that means that M2 is also minus 12. It is exactly the same. All right. Okay, moving on to perpendicular. It says, work out the gradient of the line that is perpendicular, so not the same, but the products, remember, when you have M1 times M2, it comes to minus 1. So, this was me pretending that I was whispering in your ear. Okay, so we know that the gradient we want to find is perpendicular to the line that has gradient 3. Okay, we talked about a trick to make our life easier. So if M1 is 3, we said we look at it. If it's not already a fraction, we say it's over 1, because it's the same number. Any number divided by 1 is the number that we started with. Okay, then we said we flip it, so that means M2, we flip it, so that's going to be 1/3, and then we look at it, and if it's a positive, then this one will have to be a negative. Okay, or if it was a negative, that would be positive. But in this case, M1 was positive, so that means M2 is negative and has a minus sign. But just to be absolutely sure, let's just check our work. If our answer is correct, it means that when we multiply these two gradients together, our answer will be minus 1. So 3 over 1 times minus 1/3. 3 times 1 is 3. 1 times 3 is 3. Invisible plus times a minus is a minus. Therefore, it's a minus 3. Oopsies. 3 over 3, or 3 divided by 3 is 1. So minus 1. Therefore, our answer is correct. And the gradient of the second line that is perpendicular to the first one is minus 1/3. Okay? Moving on to our next example, it says work out the gradient of the line that is perpendicular to the line with this gradient. So M1 is minus 12. So let's remember our trick. We said whatever that is, it informs our second gradient. And we said, remember, put that little line, turn it into a visible fraction. So if it's minus 12 over 1, we flip it. So it's going to be 1/12. But since M1 is a negative, then M2 has to be the opposite. Therefore, it will be a positive. Okay? Just to make things absolutely sure that we get the right answer, Let's just check. So let's multiply them together, and if the product of those two gradients comes to -1, then we are correct. So minus 12 first times 1/12. So minus times an invisible plus or a negative times a positive is a negative, and then 12 times 1 is 12, and then 1 times 12 is also 12. 12 divided by 12 is 1. So it is correct because of our proof right there. To check our work, it's always important to check our work. So our final answer is 1/12. So 1/12. Okay, so it says work out the gradient of the line that is perpendicular to the line with this gradient. So M1 is 2/3. What did we say? Our trick is we flip our fraction. So 3/2, and if the first one was a positive, the other one will be a negative. Okay, so 2 steps to our trick, and that would be correct. All right, let's look at this one as well. Again, perpendicular line, so the gradient of line 1 is -5/7. Then that means for M2, we said we flip our fraction, so 7/5. And since it was a negative, this one will become a positive. So our final answer is M2, the gradient of the second line, is 7/5. Okay. The gradient, again, we're dealing with perpendicular. So if M1 is -1/6, find the gradient of the line that is perpendicular to it. We said our trick is to flip it. So it's going to be 6 first, but I don't have to write that, so you just keep it as 6, right? And since it was a negative, this one will become a positive. But we know that with positive numbers, we don't necessarily have to place the sign behind them. If they're positive, it's just an invisible positive. And there you have it. Okay, so before you move ahead to the diagnostic test, please go back and, just pay attention, especially to the perpendicular lines, to understanding the idea. And the trick also helps when it comes to flipping and then having an opposite sign. So make sure that you understand the mechanics of it and just the basic theory before you move ahead and try the diagnostic test. Okay, I would actually sit down, and after I've watched it, I would write on a piece of paper the question on a clean piece of paper and try to answer it, and then check myself if my answer was correct. Okay, that is how we work together, and that is how we make sure that we can learn productively. Okay, so in our diagnostic test, what we're going to do is you're going to pause the video. I'm going to continue just solving. All right, and then when you're ready, you get to just click start again, and you get to watch to see the answer. If you've made a mistake, pause it, try and understand why you made that mistake, correct what you need to, and also pay attention if there's any working out to be precise about that. Okay, all right, so good luck. So the answer for this one, because they're exactly the same, would be M2 equals to 4. Again, pause, try this one as well. For this one, the answer would be minus 10 because they're parallel and so they are the same. Again, pause. We've moved on to perpendicular. Sorry, I didn't mention it. So the answer for this one is 5/7. It's the exact same. Pause this video, be careful. Now we're going into perpendicular lines. Good luck. So the final answer for this would be a positive 1/3. Again, go ahead and pause. For this one, the answer would be a negative 1/10. If you're not quite sure as to why the answer is this way, go back, watch the trick that we explained, and from the beginning actually about the products of the gradients of perpendicular lines. Watch the trick. If you still don't understand why the answer is like that, please do reach out, okay? Alright. Next one, pause the video again. Answer for this one would be a positive 4/5. Again, pause your video. And the answer for this one would be -3. Okay, and that is it for part 1. I hope you did well. I understand that sometimes the trick or the finding the gradient of the perpendicular lines can be a bit tricky, which is why we showed you the trick. If you still have some difficulty, always go back and rewatch as many times as necessary. It doesn't mean that someone has to watch a concept once and understand it. No one is expecting that. We all learn differently. We all learn at a different pace. And trust me, also, when I was in your shoes, I definitely had to watch, and I still do when it comes to new concepts. I still have to read that concept several times or watch it several times, go back, or there is no shame in watching things again and again until you get it. Okay, so I hope you did well with this video, and if you have any questions still after rewatching it and giving yourself the opportunity to try it again, then do reach out. Okay, I'll see you on the next video.